All right, guys, welcome to the ocular motility section. Let's dive in. All right, guys, let's get this first section started. We're going to go over EOMs and also some laws of ocular motility. All right, so let's start by taking it to the whiteboard. All right, guys, let's talk about Listing's plane, right? So what is Listing's plane? Really, it's just a way for us to be able to view ocular motation and ocular movements of the eyes in terms of horizontal, vertical, and then also rotational, right? So the key points to remember is that the Z plane, right, is going to be the vertical plane. If you look in your text, it's right there for you where you guys can highlight that in the text, right? Also, the X plane is going to be the horizontal axis, right? Now, the Y plane with the dotted lines, you got to think of that as like coming straight out of your computer at you, right? So the Y is going to be like behind your screen, and this arrow down here at the bottom is going to be like coming out towards you, right? So it's going to be the normal plane going all the way through your computer, right? So whenever we think about eye movements, right, what are the movements around the X axis or horizontal movements? Well, that's going to fall into what? What type of movement? That's going to be, right, exactly, elevation, right, and depression. Right? Those are going to be movements about the x-axis, right? What about movements about the z-axis, right? The vertical. That's going to be your abduction and adduction, right? So abduction or abducting, right? And then adducting. And we'll talk about those here in just a minute, about those in a little more detail. So adductions. Right? Good. So now what about the rotations are going to be about this y-axis, or this one that's going like straight through your computer, right? That's going to be your torsional, right? That's going to be your torsional movements. All right? So key take-home message with Listing's plane. You've got three different planes you're thinking of. The X plane is being the horizontal, the Z plane is being the vertical, and the Y is being the one going all the way through your computer. And then the key things, remember, with your X, you've got elevation and depression, and then for your Z, abduction and adduction, and then for your Y, you're going to have torsional movements, all right? So let's dive into our ductions themselves, right? So what is adduction, right? Well, what the key thing there is, you guys are talking to your computer right now, is ductions are monocular, right? That's what you want to circle right there, right? Ductions are going to be monocular rotations, right? So if we're talking about abduction, right, that's going to be, remember, abduction is going to be going away from the midline, right? Adduction is going to be going towards the midline, right? Elevation is going to be an upward depression or an upward movement of the eye. Depression is going to be a downward movement of the eye. And then the key thing to remember about encycloadduction and excycloadduction is that the upper portion of the eye rotates inward with encycloadduction, and the upper portion of the eye rotates outward with excycloadduction. So the key thing to remember about cyclorotation is that they're named for the upper portion of the eye. So you want to circle that in your text, right? Really important. You want to write upper portion of the eye. All right? All right, guys, let's keep on talking about versions and vergences, right? So what's the big picture important thing for you guys to remember about versions, right? So whenever we talked about ductions, we just said that they're monocular rotation, right? So whenever you guys look in your text, you'll see versions are going to be the key point being what? That's exactly right. Binocular movements, right? So it's both eyes moving in the same direction, right? You guys want to highlight that in your text. You'll see that it's also called conjugate movement. So you want to circle that or highlight that specifically in your text, right? So key points to remember. So different types of vergences. You've got dextroversion and levoversion, right? Pretty simple, right? Dextro is going to be both eyes moving to the right, okay? And then levoversion is going to be both eyes moving to your left, okay? And then also you guys will have dextrocycloversion and levocycloversion. That's both eyes rotating to the right, and then also both eyes rotating to your left. Okay? Very good. So what's the key thing about vergens to remember, right? Or vergences to remember? That's going to be the eyes moving what? In opposite directions. That's right. So you want to highlight disjunctive movements. Okay? So eyes moving in opposite directions. So you've got convergence and divergence. Obviously convergence is both eyes moving in towards the nose, right? And then divergence is going to be both eyes moving out towards your ear. Right? And then you also have, probably a little bit maybe too picky for the test, but encyclovergence and excyclovergence, that's like both eyes rotating in towards your nose and both eyes rotating out, right? Pretty talented. So you got a party favorite trick that you guys can do if those of you guys students that can do that. So, all right, let's talk about our EOMs. Now, if there's one thing in this section that you guys have to have down, right? It's going to be the EOM section, right? For boards, it's going to be super important, but also just for clinic in general, it's going to be really important to have the 6 EOMs down. Right? So when we talk about the 6 EOMs, we're going to talk about where they kind of anatomically attach to the globe. And you're going to talk about a lot of that more with Kyle whenever you guys get in the ocular anatomy section. You guys are going to hammer that really hard. So we're just going to kind of hit that overview here. Mainly what we're going to be talking about is a different type of movements that you're going to actually get, what that muscle does to the eye from primary gaze, right? Stuff that you guys are going to be remember like, oh yeah, I remember this, Ryan, we're going to dominate this stuff, right? All right, so first muscle you guys see in the text is going to be lateral rectus. What's primary action of the lateral rectus? Yeah, exactly, it's going to be abduction, right? So the eye is moving away from the midline, okay? Very good. And then you guys want to also highlight the lateral rectus inserts to the lateral side of the eye. For medial rectus, obviously the muscle is going to insert to the medial aspect of the eye. And what's its primary action? Yeah, you guys are all screaming at the camera right now. Adduction, right? So your eye's moving in towards your nose, right? So medial lateral rectus are pretty easy. So when we talk about the superior rectus, important thing you guys want to highlight there is the first sentence where you talk about the superior rectus inserts to the top portion of the globe anterior to the equator, and then the key thing there is that 23 degrees, right? So 20 makes an angle with the visual axis of 23 degrees. So you want to highlight that in your text. It's bolded in your text. You also want to circle that, right? That's going to be a key point. We're going to come back to that. We're going to draw a picture up on the whiteboard here in a minute, kind of illustrate what that 23 degrees exactly means and why it's important to us clinically and also for boards. All right. So look, what are the primary, secondary, and tertiary actions of the superior rectus? Yeah, you got it. It's going to be elevation, right? And you're also going to have encyclotorsion, right, and adduction, right? So elevation, encyclotorsion, and adduction. Awesome, guys. Let's keep on rock and rolling. You guys see inferior rectus, okay? So you want to highlight in the text, it's going to insert at the bottom portion of the eye anterior to the equator. It also creates an angle of 23 degrees, right? So circle that again. It's going to be really easy to remember that both your recti, the superior and the inferior rectus, both insert at an angle of 23 degrees with the line of sight of the visual axis, right? Excellent work, right? And then what's going to be your primary, secondary, and tertiary actions of the inferior rectus, right? It's going to be depression, right? X, cyclorotation, right? And then adduction. Excellent. Those are right there in the text. You guys want to highlight that. All right, guys, what's going to be the primary action of your oblique muscles? Yeah, you're exactly right. It's going to be that torsional movement along the the y-axis that we talked about with listings plane, right? That axis was kind of like coming right towards you, towards the camera, right? That's going to be our rotational, right? That's going to be our obliques, okay? So you guys want to look in the text. The superior oblique, right, it's going to pass through the trochlea, okay, as it goes and attaches to the posterior lateral aspect of the globe. And what's going to happen is it's going to create an angle of 54 degrees with the line of sight. So once again, for right now, just highlight that, underline it, or circle it in your text. We're going to draw a picture here in a second to kind of illustrate that. All right. So what's going to be your primary, secondary, and tertiary actions of the superior oblique, right? Number one is going to be encyclorotation, right? Number two is going to be depression, right, for the superior oblique, and then last one's going to be abduction, right? So if you guys look in your text, you'll see that encyclotorsion, depression, and abduction. All right, lastly, let's talk about the inferior oblique, right? So inferior oblique is going to attach to the inferior lateral portion of the globe, and it's going to create an angle of 51 degrees at the line of sight, okay? So superior oblique is going to be 54 degrees at the line of sight. Inferior oblique is going to be 51 degrees at the line of sight, right? Primary action of the inferior oblique is going to be what? It's going to be X cyclorotation, right? Secondary action is going to be elevation, and then tertiary action is going to be abduction, all right? So really important whenever we go through these 6 muscles, right, is they're going to be know where they're going to be located at in terms of attachment to the globe, and then also what are their primary, secondary, and tertiary actions, right? So let's take it to the whiteboard and let's draw a picture to kind of illustrate and understand those angles a little bit better, all right? All right, guys, we've got a drawing here of these angles and trying to talk a little bit more about what they mean in terms of us in clinic and also for boards. So take a second and you can kind of draw this sketch out on the side of the page there in your notes. And then now let's dive into this topic so we can talk more about what these mean. So we're looking at this picture. This is, you kind of visualize, we're looking down upon somebody's eye, right? So we're looking at the right eye from above. Okay, so we're looking at it from above. So here's their cornea right here in front, okay? And then their retina here on the back, right? The dotted black line in the center is going to be their line of sight. So it's going to pass all the way through the macula here on the retina, okay? So whenever we look at the line of sight, what these angles stand for, your superior rectus attachment point, right? Let's switch over to black real quick. All right, so your superior rectus attachment point, everything with the superior rectus I did in red just to kind of help understand this a little bit better. So superior rectus attachment point, we said it's going to be superior, right, anterior lateral, right, on the globe. And it's going to attach here, and it's going to go back towards the trochlea, right? So it's going to go all the way back here, all the way back to the optic canal, right? So as it's going through, if you compare with this attachment point and extend it out here as we're going, right, it's going to create an angle right here of 23 degrees, right, with the line of sight, okay? So that attachment point of the superior rectus as it goes back to the optic canal, if you extend it out, it's going to make an angle of 23 degrees with a line of sight. Now, if we look at the superior oblique as we talked about, right, it's going to attach here, posterior, lateral, on the superior aspect of the globe. It's going to go up towards the trochlea here, right? And then now it's going to go back towards the optic canal. So from the attachment point to the trochlea, if you extend that muscle, extend that line out, right? That's where we've got our lines going up here to the top, right? That's going to make an angle of 54 degrees with a line of sight, okay? So whenever we're talking about these angles, it helps us understand how do we isolate a muscle, right? So if we were looking at and asking clinically, how do we isolate the superior rectus muscle, right? The answer would be we would have the patient turn their eye out towards their ear 23 degrees away from their line of sight, and the only thing moving the eyes up and down would be the superior rectus, right? So whenever you move the eye and they look along that attachment line, then the superior rectus and inferior rectus, which are both at 23 degrees, would be the only muscles moving the eyes up and down, right? Now, how do we isolate the oblique muscles, right? We're going to talk about this several times, and we're going to write it in several times. You're going to see it's a key take-home message, right? Is that you isolate the obliques by looking towards the nose, right? So remember, O's to the nose, right? O's to the nose. So whenever we take our eye and we rotate it in towards our nose to that angle of 54 degrees, and remember that the inferior oblique is at an attachment point of 51 degrees. So those are relatively close enough that we can just say O's to the nose, right? Whenever you look in towards the nose, then the only muscles moving the eye up and down are going to be your superior oblique and your inferior oblique, right? Now, from primary gaze, if we look straight up, what muscles cause the eye to move up? That's going to be the superior rectus and the inferior oblique, right? Moving the eye up from primary gaze. So the only way to be able to isolate muscles is to think about this concept with the attachment points and the attachment angles. Now, do we really care about the angles whenever we look at, whenever we go and look in clinic? Do we really care about the angles that we're talking about? No, not really. So whenever you guys are looking up here, right, at our muscles, whenever we think about clinically, right, what are we talking about? We're talking about the broad H pattern, right? So whenever we have patients look in their right eye out towards their ear, that's going to be isolating the recti muscles, right, in the right eye. And when they look to their right, it's going to be isolating the oblique muscles in their left eye. Okay, so hopefully that made some sense in terms of helping understand like visually why the 23 degrees and also 54 and 51 are important, right? So as a summary point that we want to talk about here, whenever we're talking about the muscles, right? Remember the key points that we want to remember are where the muscle is going to be attached at, right? And then also we want to remember the key points of what are these angles, right? For boards, they're going to be really important, but then also for clinic, just understanding the concept of how to isolate muscles. All right, good. Now let's clear off the whiteboard, and we're going to come back and finish up with some laws of this section, and we'll be wrapping this section up. All right, guys, let's finish up this section by talking about two really important laws that we want to talk about, right? So Haring's law and Sherrington's law, right? Haring's law and Sherrington's law. So what's the big difference between those two laws? Yeah, that's exactly right, right? Haring's law is going to be one muscle in each eye, right? And then Sherrington's law is going to be two muscles of the same eye. Right, so that's your key take-home message. Good. So what is going to be Haring's law, right? Whenever we think of Haring's law, I always think of yoked muscle law, right? So what is Haring's law? It's that you have yoked muscles, one in each eye, that receive equal innervation, right? So for me to look off to my right, what's going to have to happen? My lateral rectus has to get stimulated in my right eye, right? And my medial rectus has to get stimulated in my left eye, correct? So by doing that, now my eyes are going to move off to my right side, right? Haring's law of equal innervation. If you guys look in your text, you'll see the last sentence there has those muscles tied together. The lateral rectus and medial rectus, superior rectus and inferior oblique, and then superior oblique and inferior rectus. All right, so that's Haring's law of equal innervation. Now what's Sherrington's law? Well, Sherrington's law, remember, is going to be two muscles of the same eye. And I always thought of Sherrington's law as some people call it the agonist-antagonist law. For me, it was easier just to remember the biceps-triceps law, right? So what we do is whenever for my arm to go up, right, what has to happen is that my bicep has to contract, right? My tricep has to relax. That's Sherrington's law, right? So for my arm to move up, bicep contracts, tricep relaxes, right? So same thing is going to be true for the eyes, right? So whenever I am looking out to the right, okay, and we're isolating our recti muscles like we just talked about a second ago on the video, right? Or I'm looking out to my right, I'm isolating my recti muscles in my right eye and my obliques in my left eye, okay? For my right eye to move up, right, my superior rectus has to be contracted and my inferior rectus has to be inhibited, right? Sherrington's law. Otherwise, my eye won't move, right? Same thing's true for my left eye. Whenever I'm looking off to the right, from my left eye, my obliques, remember O's to the nose. So now for my eye to move up, my inferior oblique has to contract, but my superior oblique has to be inhibited or relaxed for my eye to be able to move up, right? So those are also going to be in the text. You guys want to highlight that, right? So your muscles that are going to be connected for Sherrington's law is the last line there, right? Superior rectus and inferior rectus of one eye, the inferior oblique and superior oblique, and then lateral rectus and medial rectus. All right, guys, we got through that section. Go dominate the quiz, and I'll see you on the next section.